This is Advanced Math 12.2 homework questions. That's Advanced Math Unit 12, Lesson 2 homework questions. So I'm going off of worksheet 2, which is this here. You should have either printed it off your website or just worked off the problems off my website or picked up a copy from Clovis West. Okay, starting off with number 4. These are the problems I'm doing here. Number 4 reads 27 to the x equals 1 over 81, and it's asking us to solve for x using rules for exponents. Okay, I want to get these to the same base, and that's what we had said in notes. So the same base is going to be 3, because I can get 27 to a base of 3 as well as 81. 3 to the third is 27, and it's still raised to the x. So I'm not changing the value, I'm just changing the way it looks. We would all agree that 3 cubed is indeed 27, and the power of x is still there. 3 to the fourth is 81, so 3 to the negative fourth would be 1 over 81. And then a power to a power I multiply, so it's not 3 raised to the x, it's 3 times x. So 3 raised to the 3 times x is 3x equals 3 to the negative 4. Once we have them to the single base and one single base on each side, we can drop the bases and set the exponents equal to each other and solve. Okay, number 6. Number 6 reads 3/4 raised to the x equals 16 over 9. And taking a look, I am going to get them to the same base. Now 3/4, it's already as small as I can get, so I'm going to leave it like that. Now I'm going to try to get these to a base of 3 and a base of 4. Now I can't get 16 to a base of 4, but I can get 16 to a base of 3, but I can get it to a base of 4. And 9 I could get to a base of 3. Now they're flip-flopped, so I'm going to want to flip-flop one of them. It doesn't matter which. I'm going to leave the 3/4 as it is. That's just my choice. And I'm going to change this to 3/4 exponent negative 2. Now remember, a negative exponent makes you reciprocal the base, so the 3/4 would become 4/3. And then you would distribute a positive 2, which would make a square at the top and the bottom. So again, I'm not changing the value, just the way it looks. Okay, now that they're the same base, I can drop the bases and set the exponents equal, and that is it. X equals negative 2. Now in order to drop the base, they have to be exactly the same and only one on each side. Okay, number 16. 3 times 2 raised to the 2x plus 4 raised to the x equals 1 over 81. That's 3 times 2 raised to the 2x plus 4 to the x equals 1 over 8, not 81. Don't know where I got the 81 from. Okay. So this is the U substitution problem, and I can see, I'm going to cover the 3 because that's really the only number that's out of place there. That already has a base of 2. I can get that to a base of 2 as well as the 1/8. So I'm going to leave the 3. 2 to the 2x is going to stay. I'm going to change 4 to a 2 squared raised to the x. Again, changing the way it looks, not its value. 2 squared is still 4. The power of x is still there. That should be an x. Equals 2 cubed is 8, so 2 to the negative third would be 1/8. All right, I can multiply the powers there. So the 3 times 2 to the 2x is going to stay, plus 2 raised to the 2 times x is 2x, equals 2 to the negative 3. All right, so I'm going to use the u right in here, and I'm going to let u equal 2 raised to the 2x. So this is going to change, and we did one like this. This one actually is number 7 from notes, but I do want to do it again just so that you can hear and see it worked through again. Okay, so 3u plus u equals 2 to the negative 3. 3u plus 1u is 4u equals 2 to the negative 3. I'm going to plug the u back in. 4 times u is 2 raised to the 2x. Now, in order to go any further, I need to get them to the same base, so I'm going to change the 4 to a 2 squared. Now, in order to drop the bases, I need to have it so that it's only one base on each side. A single base here and a single base here. The right side already has a single base, so the left side, I'm going to condense it. And I do that by adding the exponents. Now, I can only add the exponents when I'm multiplying like bases. I'm multiplying, and 2 and 2 are like bases. So it's going to condense to 1 raised to the 2 plus 2x equals 2 to the negative third. Now they're down to a single base, same base on each side, so I drop the bases, set the exponents equal, and solve. Subtract your 2, divide your positive 2, x equals negative 5/2. All right, moving on, I'm going to next do number 19. And number 19 reads 2 to the x times 3 to the x equals 36. Now, we did something like this in lesson 1 where it was under the true-false section in notes, and I talked about, you look at this and you're like, what the heck do I do? These are not the same base. I cannot add the exponents. That is correct. We're not going to add the exponents, though. Think of it this way. Are these two things the same? Because it's multiplication and not addition, on this piece here, would I be allowed to distribute the exponent and call this 2 to the x times 3 to the x? Yes, I would. So I can work backwards and pull out the x. And 2 times 3 is 6 to the x equals 36, which is 6 squared. Same base, 1 on each side. X equals 2. Okay. Moving on to 21. 21 reads 2 raised to the x squared minus 6x equals 1 over 32. So I am going to want to get them to the same base, and it looks like the same base here is a 2. So I get this as 2, it's going to stay, raised to the x squared minus 6x equals 2 to the 5th is 32. You can double check that if you'd like, which means 2 to the negative 5th would be 1 over 32. One base on each side, they're exactly the same, so I can drop them, set the exponents equal, get it equal to 0 so I can factor and solve. I'll let you guys finish this one on your own. Factor, solve, you get 2 solutions, check them to the answers on the answer key on your worksheet packet and see if you get the same. Okay, moving on. 22 is the next one I am doing. And 22 reads 5 raised to the x minus 2 equals 1. This one's a little tricky, and a lot of kids, not a lot, some kids get confused with it at the beginning, but once they see it, they're like, oh my goodness, that's so easy. Okay, I need to get them to the same base. How am I going to get these two to the same base if one is a 5 and one is a 5 and the other one's a 1? What the heck am I going to do? Remember that any number to the 0 power is 1, any number except for 0. So 3 to the 0, 7 to the 0, 5 to the 0. So I'm going to rewrite this as 5 to the 0. Why? Because 5 to the 0 is equivalent to 1. Now, if I could have used base 3, 3 to the 0 would work, 7 to the 0 would work. Why would I use 5? To get them to the same base. Same base, 1 on each side, I can drop them. X minus 2 equals 0. Add the 2, x equals 2. Pretty easy once you realize and recognize what you're able to do. Okay, and lastly I'm going to do 24. And off the worksheet it reads 1/4 times 10 to the negative 2x minus 25 times 10 to the x equals 0. Now there's more than one way to approach this. I'm going to show you one way. If you'd like to see another, you can email me and let me know. All right, first thing I'm going to do is clear the fraction by multiplying by 4. I'm going to multiply everything by 4, including the 0. Okay, 4 times 1/4 is going to reduce and be gone, leaving us with 10 raised to the negative 2x, minus 4 times 25 is 100, times 10 to the x equals 0 times 4 is 0. All right, now with this, I have a negative exponent, so I'm going to change that. A negative exponent makes it a move to the denominator, so 1 over 10 to the positive 2x minus 100 times 10 to the x equals 0. All right, I'm going to clear it again because I have a fraction. This time I'm going to multiply everything by 10 raised to the 2x. Now, technically, if you wanted to, you could have multiplied up here. You could have made that a fraction and then got rid of both fractions all at one time. 4 and 10 to the 2x, did it all in one step. That's up to you. I'm going to do it two separate steps. Okay, this reduces, leaving behind just a 1, minus 100. I'm going to just write these next to each other, times 10 to the 2x times 10 to the x equals 0. And I'm even going to change the 100 to 10 squared, only so I can get them all to the same base. 100 is 10 squared. We would agree with that. 10 to the 2x, I just moved to the middle, and then 10 to the x at the end. 10 to the 2x times 0 is 0. Okay, 1 minus 10 raised to this. Since they're all the same base, I can add all the exponents. 2 plus 2, x plus x. That's 2 plus 2x plus x. So that ends up being 2 plus 3x equals 0. I'm going to add over the 10 to the 2 plus 3x. And kind of like number 22, I want to get this to a base of 10. 10 raised to what power is 1? And now that we have them to the same base, 1 on each side, we can drop them and set them equal. Divide the 2, subtract the 2, divide the 3, you get negative 2/3. All right, that is it for this section of homework questions.